This is part 2 of relations and functions. Relations and functions can be shown in different ways. We could have a table of values, a graph, formulas. That's often how it's written for functions. You could express it in words, a set of ordered pairs, or a picture. So in part 1 we went over basically many different relations. And then at the end we defined a function, which is a special kind of relation. In a function, each input always has exactly one output. So I drew a little picture of, you could think of this as a function machine. You input something, it goes through the function machine, and it gets spit out, and that would be the output. Sometimes people think of this as inputting an X and out comes a Y. Okay, that's one way you might think of it. And another common notation is you input an X, and what comes out is called f of X. That's how you read this, f of X. It's not a multiplication. Okay, it's a new notation that you might not have seen. Okay, so we'll be seeing this notation. So we read this f of X. What it means is X has gone through the function machine, and this is the output. Another word that's sometimes used instead of output is image. We might say Y is the image of X, or f of X is the image of X, etc. Just a couple more vocabulary words. Whatever you put in is called the independent variable, because you can put anything in there. And then whatever comes out is called the dependent variable, because the image or output depends on what you put in. So if you input X and out comes a Y, we say that X is the independent variable because that's what goes in, and Y is the dependent variable because that is what comes out. It depends on what you put in. So the most important thing to notice here is the definition. In a function, each input always has exactly one output. So for instance, if somebody puts a 2 in this particular function machine and a 4 comes out, that means the next person who comes by and puts in a 2, a 4 will come out as well. It's not like when one person puts in a 2, they get a different output than when somebody else puts in a 2. So we're going to look back at some of the relations we did in the previous video and see if they were functions or not. This was the first example. We had input and output. I wrote it in several ways. And if you look at the picture here, notice if your input of 1, you have 2 different outputs. So this is not a function. Another way to notice it is that in my table, I've got 1 listed twice with 2 different outputs. Or if I look in my ordered pairs, I've got 1 listed twice with 2 different Y values. And lastly, if you look at a graph, if you see 2 dots, 2 parts of the graph on top of each other, that means for this X value, there's 2 different Y values. So this is not a function. This is another relation we did where we named the husbands of certain people, Amy, Beth, Cindy, and Denise, and I used the abbreviations ABCD. So notice A goes to John. In other words, John's the image of A, which means John is the husband of Amy. And then Beth also has John. Now this may particularly the same John, I just said the names. C goes to Mark, D goes to Steve. So for each input, there's really only one output. In other words, we don't say that Amy is married to 2 different people, for instance. Okay, so this is a function. You could also tell by looking at your ordered pairs, you don't have any of your X values, you might think of that, the names of the ladies, more than once. This was another relation. I looked at the graph, and then we wrote the ordered pairs. And there's two ways to see that this is not a function. First of all, notice right here we've got two y values for this one x value of 1. And also if you look at the ordered pairs, you've got 1 listed as the x value in more than one ordered pair. So this one is not a function. So let's reiterate. In a function, each input always has exactly one output. So note what that really is saying, that in a function, for each input, the output, or image, must be absolutely predictable. Each input x has exactly one and the same output. So if I have a function where if I put in a 2, a 4 comes out, anytime I put in a 2, a 4 comes out. Here's an example. Is y equals 3x a function? Now notice this is the first time I've written it as a formula. What it's saying is that x is the independent variable and y is the dependent variable. So if I give you a number x, you're going to multiply by 3 to get the value of y. It's absolutely impossible to write all the ordered pairs, right? You can graph this if you'd like to get an idea what it looks like. And this is a line with a slope of 3 going through 0, 0. So it looks something like this, because there's infinitely many ordered pairs for this relation. The question is it a function? Is it possible that if I put in one value of x, I'll get a different value of y, like a different person might? And actually the answer is no. For every value of x, there's going to be exactly one y. So if I put in a 7, the y value is going to be 3 times 7, or 21. So that's one ordered pair. If I put in a negative 2 for x, the y value will be negative 6, etc. So there's infinitely many ordered pairs, and yes, this would be a function. Now, another way of writing y equals 3x is using what's called function notation, which I introduced a little bit. F of x equals 3x. So notice, instead of writing y, I'm writing f of x, and that's very common. Instead of writing y, when we're talking about functions, we often write f of x. Now, the reason for the notation is, notice what if I wanted to say, well, what's f of 7? What that means is I'm putting in 7 for x to get 21. So f of 7 equals 21 corresponds to that ordered pair, 7, 21. So you put your x value in, and then you replace that for x in this formula for the function. So how about if I did f of m? Well, that means in place of x, right, look at what I've put a box around, I'm going to put in m. So f of m is 3m. Now how would I write that as an ordered pair? It looks funny. Well, the x value is what I put in, m, and what comes out is 3m. So it's an ordered pair, but you just don't see a particular number. If I have f of negative 2, I have 3 times negative 2, which is negative 6. That corresponds to that ordered pair, negative 2, negative 6. And there are infinitely many ordered pairs here. And what you have to determine is whether or not it's a function by, is it possible to put in one input and get a different output, then it will not be a function. All right, we'll be doing a lot more of these on the next video.